Okay, welcome to day 6, applications with derivatives now. The last 2 days we've been doing anti-derivatives. We have been looking at the relationship between displacement s, velocity v, and acceleration a, and actually been working in reverse by taking the antiderivative, saying that v is the antiderivative of a, and s or h or whatever, d is the antiderivative of velocity. Well, now we're going to do what we're used to doing, is taking derivatives, and that means velocity. I'm going to give you the s, or the displacement, and velocity is the derivative of s, and acceleration is the derivative of v, or acceleration is the second derivative of s. So I have to give you some sort of displacement equation, or height equation, or distance equation. So in this example, I'm giving you that this is the height of an object thrown up in the air, where t is measured in seconds. What is the initial height of the ball? Well, the initial height, I just plug in 0, I get 64, and its units are feet. And then it wants the initial velocity. So first I have to figure out the velocity equation, and that's just taking the derivative of the height equation. I get velocity is equal to negative 32 t plus 48, and if I want the initial velocity, I just plug in 0, and I get 48, and it'll be feet per second. Units are important. When does the object reach its highest point? Well, when is time, and I take my velocity equation and I set it equal to 0. So 0 equals negative 32t plus 48. 32t equals 48. T equals 1.5 seconds. And what is its maximum height? Well, its maximum height is doing h of 1.5 seconds, which will be, I'm going to move this over, h of 1.5 is going to be negative 16 times 1.5 squared plus 48 times 1.5 plus 64, and the max h, which happens at 1.5 seconds, is 100 feet. When does it hit the ground? Well, that's when h equals 0. I do negative 16t squared minus 48t plus 64. I divide out by something to make it easier. I can see everything has a 16 in it, so I get 0 equals t squared minus 3t minus 4. I could factor it. T plus 1, t minus 4. And obviously t equals negative 1 is not possible, so I get t equals 4 seconds. And what's its velocity? Well, I just do the velocity at 4 seconds, which is going to be negative 32 times 4 plus 48. And the velocity at 4 seconds is negative 80 feet per second. So maybe a little bit easier than what we were doing before. We're not doing antiderivatives, we're doing derivatives. So I'm giving you the displacement, or the distance, or height equation. I'm finding velocity and acceleration from there. Very similar problem, except this one is in meters instead of feet. So my initial height is when time equals 0. I get 75 meters. What is my initial velocity? Well, I have to find the velocity equation by taking the derivative of this, and I get negative 10 t plus 10. So my initial velocity is 10 meters per second. Again, v is equal to h prime, because all I have to do is take its derivative. When does it reach the highest point? That's when v is equal to 0, or negative 10t equals plus 10, 10t equals 10, t equals 1 second. What's this maximum height? Well, all I have to do is plug this into the height equation of negative 5 times 1 squared plus 10 times 1 plus 75, and I get the max height at 1 second is equal to 80 meters. When does it hit the ground? Well, it hits the ground when h is equal to 0, which is negative 5t squared plus 10t plus 75. I see I could divide out by negative 5. I get 0 equals t squared minus 2t minus 15. I could factor that as t plus 3, t minus 5. I get t equals 5 seconds. Obviously t equals negative 3 cannot be done. And the velocity at 5 seconds is going to be negative 5 times 5 squared plus 10 times 5 plus 75. And my velocity at 5 seconds is equal to negative 40 meters per second. Like I said, maybe a little bit easier than doing all those ooh, that's not right. That's not right at all. It is negative 40, but my velocity equation, that was my height equation, my velocity equation is going to be negative 10 times 5 plus 10, and that gives me my negative 40. Lost my focus for a second. Okay. Let's complete this chart. We're looking at displacement. Sometimes it's distance, our height, but really we're going to look at it where we have a particle moving on a number line. It's only going to move left or right on a number line. So when its displacement is positive, the particle is on the positive x-axis. Obviously when it's negative, the particle is on the negative x-axis. When it's equal to 0, the particle is at the origin. Wow, I can't even spell. At the origin. So this particle is just moving left or right on a number line. Let's talk about velocity. Well, when my velocity is positive, my particle is moving to the right. When it's negative, the particle is moving left, and when it's equal to 0, the particle is stopped. It's not moving. And then finally, let's look at acceleration. When my acceleration is positive, the velocity is increasing. When it's negative, the velocity is decreasing. And when it's 0, velocity is constant, just like over here, when its velocity is 0, its position is constant because it's not moving. Okay, here we go. Let's do an example. I give you an equation for the position of the particle. S of t equals 4t squared minus 48t plus 3. That's its speed after t seconds. But notice the restriction. It's only from 0 through 10 seconds. Not before 0, not after 10. Velocity equation, well, velocity is just s prime. So v of t is equal to 8t minus 48. And its acceleration is the derivative of velocity, so my acceleration equation is just equal to 8. When is the particle stopped? Well, what does it mean to be stopped? Particle is stopped when velocity is equal to 0, so I take 0 equals 8t minus 48, 8t equals 48, t equals 6. So it's 6 seconds is when it stopped. Okay? When is it moving left? Well, when is it moving right? Well, guess what I'm going to do? I'm going to do a number line again. Here's my number line. But this isn't going on forever. It starts at 0 and ends at 10, based on what I had earlier. I'm going to put 6 on this number line. Okay, this is the number line for the velocity, and right here the velocity is equal to 0, and my leading term is equal to 8t, so it goes positive, negative. Therefore, it is moving left from 0 through 6. It is moving right from 6 through 10. So then it says, what is its maximum velocity? Well, let's look at acceleration. Okay, the acceleration is equal to 8, which means it's always 8 or always positive. That means velocity is always increasing. Okay? From 0, that means if the velocity is always increasing, the maximum velocity will be when t is equal to 10 seconds, because that's my maximum time. So I put that into the 10 into the velocity equation. I get 8 times 10 minus 48, and I get my maximum velocity is equal to 32 feet per second. Well, my velocity equation is pretty easy. My velocity equation is s prime. Here's my s, t cubed minus 12t squared plus 45t plus 2. And my velocity equation is going to be 3t squared minus 24t plus 45. That's my velocity equation. My acceleration equation is just, well, acceleration is v prime. So a equals 6t minus 24. So I have a little bit more difficult of a problem because I actually have something to do. Acceleration is just more than a constant number. But the same process as before. When is the particle stop? When v is equal to 0. So I do 3t squared minus 24t plus 45. I'm going to have to factor this. I can see you can divide everything by 3. So 0 equals t squared minus 8t minus 15. And if I factor it, I get t minus 3, t minus 5. So I get t is equal to 3 seconds, and t equals 5 seconds. this is when it stopped. Was it moving left and right? I'm going to make a number line again. So here's my number line. Nope, that's not right. I can't go on forever. I have 0 and I have 10. Those are the beginning and end based on what I said before, 0 to 10 seconds. I have a 3 on here. I have a 5 on here, and this is when things are 0. I have a leading term of 3t squared because this is a number line for the velocity, so it goes positive, negative, positive. So it's moving, let's see, I'll do left first. Left from 3 to 5, and it's moving right from 0 to 3 in union with 5 to 10. So what is this minimum velocity? Well, I'm going to use my acceleration equation. So when a equals 0, that means my velocity would be a min or a max. So if I take my acceleration equation, 6t minus 24, etc. equals 0, I get t equals 4 seconds. And that could be a min or a max. I'll have to see. I'm going to have to make a number line. Again, 0 through 10. Right here is 4. That's a 0. This is my number line for the acceleration equation. My leading term is 6t, so it goes positive and negative. So if we recall, if a equals v prime and it goes negative, 0, positive, this is a min. So right here at t equals 4, that is a minimum value for velocity. So I have to find my velocity at 4 seconds, which is 3 times 4 squared plus 24, not plus, minus 24 times 4 plus 45 using my velocity equation. So my minimum velocity, what happens at 4 seconds, is negative 3 feet per second. And there we go. That's all the notes for today. Thank you.